Okay, we have many applications of determinant. As we've seen, we can use determinant to solve systems of equations, but some other areas that we're going to look at is we can use our determinants to help us find the area of a triangle that is not a right triangle. We can also find figure out if 3 points are collinear or lie on a line, and we can also find the equation of a point if we equation of a line going through 2 given points. So let's start with looking at finding the area of a triangle. So the area of a triangle with vertices x1, y1, x2, y2, x3, y3 is equal to plus or minus 1/2 times the determinant of, and to make this determinant, you write your first point, your second point, and your third point. Whereas your first column is your x points, your second column is your y points, and then you put in placeholders of 1s in the third, because remember, we have to have a 3x3 matrix in order to find the determinants. All right, so to find the area of a triangle, that's going to be equal to plus or minus 1/2 times by the determinant, and then we have our first point, second point, third point, placeholders of 1 for our third column. Now this is a 3x3 determinant, so in order to find a 3x3 determinant, we need to copy down our first and second columns. And then to figure out this determinant, remember our determinant is found by taking the product of our diagonals down. So our first diagonal down would be 2, plus the product of the second diagonal down, which is 0, plus the product of the third diagonal down, which is 6. So 2 plus 0 plus 6 will give us 8. And then we take our product of our diagonals up, so the first product is 8, plus the product of the next diagonal up, which is 3, plus the product of our final diagonal up, which is 0. 8 plus 3 plus 0 gives us 11. And remember, our determinant is determined by taking our diagonals down minus our diagonals up, which would be -3. Now, since my determinant is negative, I would take the -1/2 and times it by -3 to give us a positive area of 3/2. All right, you try the next one. To find the area of this area that goes a triangle formed by these 3 vertices, we use the following formula. Now to find this 1x1 determinant, I copy down my first and second rows. I find my products of my diagonals down, and sum those together. Then I find the products of my diagonals up, and sum them together, and then our determinant is the sum of the products down, diagonals down, minus the sum of the diagonals up. And again, we have a negative time, so we multiply by -1/2 to give us a positive 3/2 as our area. The third thing that we can use determinants for is to test and see if 2 points are collinear. Now this test is, we're going to set it up just like we did for the area one. We're going to have our first, second, and third point put in our determinant in our placeholders of 1. And then if I find that determinant and that determinant answer is 0, then all 3 of these points are collinear. That means they lay on the sine line. If I get any other value besides 0 for my determinant, they are not collinear. So setting up this one, now we'll copy down our row 1 and row 2. And then to find the determinant of this 3x3 matrix, I take my product of my diagonals down, sum those products together to get -11. Then I'm going to take the product of my diagonals up, sum those results together and get -5. So my determinant would be -11 minus -5, or -11 plus 5, which is -6. So since -6 is not equal to 0, we can conclude that these 3 points do not lie on a single line. They are not collinear. All right, you try the next one. So to test and see if these 3 points are collinear, we first set up our determinant by listing our 3 points and then adding placeholders of 1 to make it a 3x3 matrix. Then we find the determinant of that 3x3 matrix by copying down our first 2 columns, finding the product of the diagonals down, and then the sum of the products of the diagonals up, taking the sum of the products of the diagonals down minus the sum of the products of the diagonals up, I get 0. Since my determinant is equal to 0 when I use these 3 points are collinear. We can expand this test of the test to see if 3 points are collinear to find the equation of a line given going through 2 points. So to test for if 3 points are collinear, I would set this up using our same thing we just did, but I would just do x and y, my unknown point, and then I would plug in the x and y, the first point given, and the x and y, the second point given. Again, put in 1s as placeholders to get a 3x3 matrix. And then if these are on a line, then all three of these points should be collinear, so I would set that equal to 0. And then I would then solve the resulting equation for x and y. So let me show you how this is done. So for this example, we want to find the line that passes through the point 20, 50 and negative 10, 25. So this is how I'd set up my determinant. Copy down my first and two rows. And I'm going to find the determinant. So I want to take the products of my diagonal down. Well, x times 50 times 1 is 50x. And then plus the product of the next diagonal down, which would be negative 10y, plus the product of the next diagonal down, which is 500. Then I need to take my diagonals up, and the product of the first diagonal up is negative 500, plus the product of the next diagonal up is 25x. And finally, the product of the last diagonal up would be 20y. Now, I need to take my sum of my diagonals down, which would be 50x minus 10y plus 500, minus it from the sum of my diagonals up, which is negative 500 plus 25x plus 20y, and equal that to 0. Okay, so I'm going to distribute the negative and get rid of the parentheses. And then combine like terms. So all my x terms I combine together to get 25x. Then I'm going to combine my y terms together to get negative 30y. And then my constant terms together to equal 1,000. So this is an equation of my line that goes through these points. But we always want to write our most simplified answer. So I noticed that 5 is a GCF of all three of these numbers. So if I factor out the 5, I'm left with 5x minus 6y is equal to 200. So 5x minus 6y plus 200 equals 0 is the equation of the line that goes through these 2 points. Now it's your turn. I want you to find the equation line containing the points 2, 4 and negative 1, 3. Okay, we would start by setting up our determinant. So we have x, y, the point 2, 4, and the point negative 1, 3, placeholders of 1. And then again, to find this determinant, copy down my first two columns, sorry. And then I'm going to find the product of the diagonals down, which that would be 4x, plus the product of the next diagonal down, which would be negative y, plus the product of the last diagonal down, which would be 6. Now I'm going to find the sum of the products of the diagonals up. So the products of the first diagonal up is negative 4, plus the product of the next diagonal up, which is 3x, plus the product of the last diagonal up, which is 2y. So remember, our formula is that this determinant must equal 0 for them to be on a line. So we have our diagonals, our sum of our diagonals down minus the sum of our diagonals up is equal to 0. Distributing that negative through the second parentheses. And now combining like terms, 4x minus 3y will give me an x. Negative y minus 2y would give me a negative 3y. And then 6 plus 4 would give me a positive 10. So the equation of the line passing through these two given points would be x minus 2y plus 10 equals 0.